Good afternoon, everyone. Today, I want to talk a little about enhanced safety and efficiency and how you can do that by optimizing underdeck access. So today, although our company specializes in three things, WebDeck, WebNet, and WebCatch systems, given the time, I will only concentrate on WebDeck. First of all, just a single slide on web. We provide unique engineered suspended access solutions and protection against dropped object. Our engineers are based in Scotland, and the manufacturing side of our business is located in Jewar in India. So if anybody does need any further information on Web Systems International, I'll provide a slide at the end with contact details. So to begin with, before we can look at innovative solutions, I think it's important to see the complex challenges that are being faced by industries throughout the world, not just in India. So there are probably three categories that we can look at. The first of these, as always, has to be safety. So in relation to access, this can go from accessing the underdeck safely, preventing falls from work platforms that may be used, dangers from working over water, and then obviously protection of employees and also assets from falling debris. The logistical section, as I would call it, relates to how access interfaces with traffic disruption. So minimizing the impact on road or rail traffic due to ground up scaffolding or other access methods. Then you also have the difficulty of simultaneously working on extensive underdeck areas. More and more, particularly, and you will know this more than me, that having space to offload large amounts of access equipment is becoming more and more of a challenge. So these are real life challenges on every access project. Then we have load limits on weakened structures. As more and more infrastructure is aging, then the structures themselves become weaker, and this then imposes a critical need to assess and respect the structural integrity when deploying any kind of access equipment. And then the final category of consideration has to be related to costs defined by budget constraints. As everybody knows, budgets are becoming tighter, but also the cost to the environment. Are we using the most environmentally insightful methods of carrying out access, particularly when it comes to looking at carbon footprint for moving materials about? And then we have to look at preservation of historic buildings and structures. So these are the complex challenges that one would face when looking at any construction or rehabilitation project. I'm using this as a proxy or as an example to show you in real life what these problematic areas look like. So you can see that, particularly in older structures, congested areas can make ground up scaffolding very difficult to use. Weak structures make heavy suspended scaffolding impractical. And then if you're having to build from the ground up, you could be causing disruption to ongoing operations, and the traffic flow needs to be minimized. If you're working, for example, in a heavy industry, like in this example, the steel industry, you may have inclined conveyors to deal with. So the very inclination of these assets can make access to the underside a bit more problematic. So these are some of the problems that I'm sure some of you will face most of the time when you're considering access for your project. We then look at what are the current or the traditional methods of gaining access. Now, the main ones obviously are scaffolding and towers, etc. And these have distinct advantages and some disadvantages. The main advantage of scaffolding is that obviously it's widely understood and accepted. It's globally available. It uses standardized components for the most part, and there's a large skilled labor pool capable of installing. However, as we're now moving further into the 21st century, disadvantages do appear when you're considering traditional methods. These include the fact that if you have to gain access to quite a height, then slower installation can take place for large areas. Ground up scaffolding definitely obstructs traffic, and then high structural loads when using traditional suspended scaffolding can be a problem. The risks involved in installing these systems are greater compared to more modern methods of access, such as, for example, rope access techniques and some of the more modern access systems. So I'm going to show you one solution and then talk you through how that might be used to make systems safer and far more efficient. So this is a product that we manufacture that's known as WebDeck. And I've described this as using a wafer of WebDeck, because you can see from this graphic that it doesn't matter what height you need access to, you will only ever have one wafer thin layer of decks completely encapsulated, allowing safe working for the people on it. And probably more importantly, from an efficiency point of view, there's absolutely no need for obstructing the road below. You can see that better in this very short video. It lasts less than a minute. And this one shows a particularly difficult situation where you have to gain access over water below a bridge. So what you're looking at here is the WebDeck being installed mostly by rope access technique. And then once it's in place, it can be used to carry out a variety of heavy activities. So you can see that this is being deployed onto steel rope or catenary wires, which is one version of the system. The second version, which I'll show you, involves deployment onto trusses. Again, another scenario might be if any of your work has to be carried out close to water. So for example, on a jetty, there are two illustrations of advantages here. One of them uses a graded version of the WebDeck so that any water coming up can actually flush through the deck and then wash away, leaving a very good and secure anti-slip surface. And I'll show you a short video of that in a second. The second thing that I wanted to draw your attention to is that with WebDeck, the anchor fixings can be placed into concrete using chemical fixings, resin fixing. You can see clearly in the next few seconds how the grated version of the deck works. So you can see the water flushes in and then it washes away again. And then the grating itself provides a very good anti-slip property. More and more, we are looking at new scenarios, and one of them that is coming to the fore includes, for example, large factories and data centers. Now, the issue for access here is that from the client or the customer's point of view, they want to keep production rolling or keep data service in place without interruption over long periods of time. With that as one of the constraints, you then have to consider how is access achieved. So you can see here in this graphic that WebDeck is suspended from the structural soffit, but above the working area, so that people can carry out the productive side of the business without interruption. And then very quickly here, we're just looking at a railway bridge where access is gained to the underdeck whilst operations can continue. So these are a few real world examples of where WebDeck has been successfully used now. So very often it's used in offshore situations. So for example, oil and gas platforms. But you can see from the variety of photographs that I have here that it can be used successfully below bridges, jetties. And then if we look at some modern applications, on the right-hand side, you're looking at a stepped version of the WebDeck platform, and this is used on an airport canopy in the new international airport at Jewar. So you can see here that the WebDeck is following the incline of the canopy quite successfully, and then we can provide encapsulation and also laddered interfaces between levels if required. So that's airport as a new consideration. And then on the bottom right, we also have football stadia. So again, it makes sense to keep the stands clear whilst access to the canopies above is being obtained. The type of work that can be carried out from a web deck platform, these include bridge inspections and repair, all lightweight work, but also including the heavier stuff that may include bringing heavier pieces of equipment onto the deck. This is an example of an encapsulated web deck. Again, this one's used in a steel industry location, and you can see that it's following the incline. And given the time that we have, I'm just going to skip through a few of these. I wanted to show this one because it illustrates the two systems. If you have anchor points available at either end, so for example, going into the abutments below a bridge, then you can have a catenary wire system that runs the length of the asset, and then you can see that the decks are quite simply clipped onto the catenary wire, locked in place, but the actual load is taken by strategically placed pickup chains and either beam clamps or wire rope slings at the top. So that's using our catenary wire version of the system. And then on the right-hand side, you can see the truss version of the system. So in other words, where you don't have the opportunity for end anchors, then you would use independently suspended trusses. This is what the decks look like. They have standard lengths of 1 meter, 2 meter, and 3 meter, and they all have a uniform width of 600 millimeters. Now, the reason for that is that for manual handling, and particularly perhaps for getting through tight spaces like hatches into silos, etc., 600 millimeters is a good width. The system is very lightweight. It averages 20 kilograms per square meter, or just over 4 pounds per square foot. The loading capacity, it can take 300 kilograms per square meter, or 3 kilonewtons per square meter, with a 3-to-1 factor of safety. And both those decks are interchangeable with both the catenary wire and also the mega truss system. This gives you a better idea in graphic form of how this system would be made up. So you can see the decks in place. Also, the containment is done with side encapsulation netting. That can also be enhanced with a proprietary handrail system. And again, this will come down to regulatory compliance, or indeed it could be organizational compliance. So some clients wish a handrail, some clients look out for encapsulation netting, and some of them actually want both together. Then we also have toe boards to stop anything falling off the edge. And as I was saying before, you can either use wire rope slings or beam clamps to attach the pickup chains at intervals. This again is just an illustration of a full encapsulation below a railway bridge. And you can see here that the bottom layer of decks has been used for carrying out the work, and the top layer can be used for creating a walkway. So it might be that you use a combination of decks. And then this is just to illustrate how the system is secured. So I was mentioning earlier on that the deck is clipped into position. It uses these hooks to locate it, but there is a unique hook and clasp mechanism. And when the flap comes down, the clasp comes up, and then the deck is completely locked into position. So the focus here is on safety and on efficiency. These can be deployed very rapidly, and if anyone's interested, I can send across to you case studies with individual details from customers on time saved, etc., etc. Finally, I'm just going to show a couple of slides. This is WebNet, which is a work positioning netting solution. And again, similar to WebDeck, it can negate the need for having anything built from the ground up. Traditionally, these can be used for lightweight inspection work or indeed providing a walkway. And that, for the purpose of this short presentation, was just to give you an idea of at least one innovative approach to solving some of the issues that we looked at the conundrum at the very start of my presentation. So thank you very much for your time.